Lesson 8.8, volume of composite solid figures. In this lesson, we're going to be dealing with more exotic looking three-dimensional shapes, but when you really break down the details of these shapes, they're just combinations of rectangular prisms. In other words, if you take a look at this first problem, if I imagine slicing this figure this way and this way, and I called this box section A, and this portion section B, and this portion section C, we can visualize that as long as we apply the same strategies for calculating the volume of one of these sections on its own, finding the total volume of a figure like this is simply totaling up the individual volumes of the parts. Let's get started. For section A, we're dealing with a length of 3, a width of 2, and a height of 7. So volume of section A, oops, I went off the page there. The volume of section A could be described as, what I say, the length was 3 times 2 times 7. Same thing for the identical section B. We're talking about a length of 3, a width of 2, and a point-to-point height of 7. Section C has a point-to-point length of 18. Its width is still the same though, isn't it? It's 2 centimeters deep up here, which means this is still 2, which means this is still 2. So, which means this is still 2. It's 2 deep all around. And the height? We have to figure this out. Our point-to-point height here is 10 centimeters. Our point-to-point height here was 7. So to figure out the part that we're interested in, which is here to here, we'll calculate that by doing 10 minus 7. This is 3. Now, let's start to calculate our individual volumes. Volume of section A is 3 times 2, which is 6. And then 6 times 7 is 42. Okay, so same thing is going to be true for B. So I got 42 here, and I'm kind of scrambling for space here. I got 42 for section A. I got 42 for section B. The volume of C is going to be 18 times 2 times 3. I could do 2 times 3 is 6. 18 times 6, let me do a side calculation. 6 times 8 is 48. The 8 will come down, 4 gets carried. 6 times 1 is 6, plus the 4 is 10. So I get the section, or the volume of section C is 108. Now, let's total up the 3 sections to find the total volume. 2 and 2 is 4, 4 and 8 is 12. 2 comes down, 1 gets carried. 1 and 4 is 5, 5 and 4 is 9, and then the 1 comes down. I get a total volume of 192 cubic centimeters. Number 2. This shape, I can slice it like this or slice it like this. As long as I'm careful and accurate with my dimensions, I'm going to get the same answer. But just for fun, I'm going to slice it this way. So I'm going to call this portion part A and this portion part B. For A, I want to figure out my length first. I know from point to point this is 24, and from this point to this hidden point, it measures at 18. So I want the difference between 24 and 18. 24 minus 18 is 6. So my length is 6. My width is going to be 5. And my height is 10. Now, section B, my length is going to be 18, point to point. My width is 5. And my height is 2. 6 times 5 is 30. 30 times 10 is 300 for part A. For part B, 5 times 2 is 10. 10 times 18 is 180. We'll add them up, and we get a total volume of 480 cubic millimeters. I would have loved to have done number 3, but we haven't been given enough information as far as some of these detailed measurements to find the total volume. So we're going to skip that one and move on to number 4. A door is shaped like a rectangular prism and measures 6 2/3 feet tall by 3 feet wide by 1/4 foot deep. How much space does the door take up? Well, we need to multiply these 3 dimensions together, of course, in whatever order we like. 6 2/3 times 3 times 1/4. So I think I'm going to multiply these 2 first. This I'm going to convert to an improper fraction. 3 times 6 is 18. 18 plus 2 is 20. Whole number 3, I'm going to write as itself over 1. Do you see an opportunity to use cross-canceling? 3's cancel, don't they? So inside the parentheses, we end up with actually 20. So 20 over 1 times 1 over 4, I can use cross-canceling again. 4 goes into itself once, 4 goes into 25 times. 5 times 1 is 5. 1 times 1 is 1. I get 5 feet. That's my final. And I think for today's purposes, we're going to skip that and call it done. Nice job.